Why is distributed backend cache consistency difficult? Have you ever wondered why keeping data consistent across multiple cache nodes can be such a challenge? Let's break it down in a way that makes sense. Distributed backend cache consistency is tricky because it involves multiple cache nodes spread across different servers or locations. Each of these nodes needs to show the most current data, but several factors make this hard to achieve. First, think about data update propagation delays. When the main database changes, those updates need to reach all cache nodes. However, network delays and processing times can slow this down. During this time, some nodes might serve outdated data, leading to inconsistencies. Next, consider the use of multiple cache nodes and replicas. Large systems often deploy several cache replicas to balance the load and improve performance. Ideally, all replicas should hold the same data, but synchronizing updates across them can be complicated. If one replica gets updated later than another, it can lead to temporary differences in the data they serve. Cache invalidation is another challenge. This process involves removing or updating stale data in the cache. In a distributed system, coordinating this across nodes is tough. It requires tracking which cache entries need to be updated and ensuring all relevant caches are cleared or updated quickly. If there are mistakes or delays, inconsistencies can arise. There is also a trade-off between consistency and performance. Strong consistency means all caches are perfectly synchronized, but this can slow down performance. Many systems choose eventual consistency, which allows for temporary inconsistencies to improve speed. However, this makes it harder to ensure cache correctness. Concurrent updates can add to the confusion. When multiple updates happen at the same time, distributed caches need to resolve conflicts. Techniques like last right wins can help, but they also add complexity and might still lead to temporary inconsistencies. Monitoring these caches is another hurdle. Detecting when caches become inconsistent, especially in large systems, is difficult. Effective monitoring needs precise measurements without false alarms, which can be hard to achieve. Without good observability, inconsistencies can go unnoticed for a long time. Lastly, there is the thundering herd problem. When many clients request data that is not in the cache at once, the system can become overwhelmed. This can lead to delays or failures that worsen consistency issues. In practical backend development, these challenges mean developers must choose caching strategies carefully. Options like write-through, write-behind, or time-to-live expiration can help balance performance and consistency. Using distributed consensus algorithms or conflict resolution techniques can also help maintain consistency, but they add complexity to server-side logic. Understanding these challenges is key to designing scalable and reliable backend systems that use caching effectively while keeping data accurate and user experience smooth.